Salam and welcome everyone. So today we're going to be working on the question on the screen that says a sample of 4.50 grams of methane occupies 12.7 dm cube at 310 kelvins. So first of all, you're given the mass of gas, and that gas is methane. So we've been given the identity and the quantity of the gas. Whenever you're given the mass as well as the identity of a gas, just know that indirectly they're trying to tell you that you have to solve for a number of moles. So that's always what ends up happening in chemistry. So put that in mind. And then you're told that it occupies 12.7 dm cubed. 12.7 dm cube is the same thing as the volume at 310 Kelvin. So this is the temperature. Calculate the work done. Okay, so we're asked to calculate work when the gas expands isothermally. Okay, in a reversible process. So this is good because this is the key information we need to solve this, because it's possible for a gas to expand isothermally when we're dealing with whenever we're dealing with a question that asks us to solve against constant external pressure. But because they said this is a reversible process, they've made our work easy because now we can just write down what the formula is. So for to determine work that occurs in a reversible process when the gas expands isothermally, we have W equals negative nRT ln, so lateral log the V final divided by the V initial. So that is what it is. So in a reversible process, causing its volume to be increased by, so not increased to, of course, it's not increased to because this is going to be less than increased by. So whatever the initial um volume is, which we're told here is 12.7 dm cubed, the final volume was just going to be this, whatever the initial volume is plus the change in volume. So hence V final here, which we don't know, is just going to be the V initial plus the change in volume. So the V final is just going to be 12.7 dm cubed plus 3.3 dm cubed. So the V final is just going to be 12.7 plus 3.3 is the same thing as 16.0 dm cubed. So that's how you work with this one. So we know what the V final is. Now we have to determine the number of moles because we actually know what the gas constant is. Anytime you're dealing with a work problem, remember that the unit for work is either Newton meter or joules. So one of the two, Newton meter or joules. So you have to pick the gas constant that actually matches the units that we are trying to solve for in the question. So looking at this, we have to look for a gas constant. We have to use the gas constant that has the unit of joules or Newton meter, and we have our R to actually be 8.3145 joules per mole Kelvin. So all this information is necessary because we ultimately want to write down all the information that we're given. So when we put all of this information and we substitute to find work, we already have all the proper we have all that is we are supposed to have, like all the proper information. So the last thing we have to solve for is number of moles. We're told that the gas is methane. So, and we're told the mass of the gas, mass of CH4 or methane is 4.50 grams. So remember the number of moles of any gas is mass divided by molar mass. So the number of moles of methane gas is going to be mass of methane gas, CH4, and then the molar mass of methane gas. So number of moles is going to be, mass is going to be 4.50 grams divided by the molar mass of divided by the molar mass of the CH4 gas is 16.04 gram per mole. So of course, we input this information in the calculator, we end up with 0.28055 mole. So now we have all the information we need to substitute. So we have work done, let's not forget, equals negative R nRT ln V final divided by V initial. So we're just going to substitute into information. We have work done now equals negative 0.28055. So the number of mole times, we'll go back to see what R is R is 8.3145 joules per mole Kelvin. 8.3145 joules per mole Kelvin. Okay, times temperature, which is 310 Kelvin. So all of that information, ln V final divided by V initial. So that's going to be, V final is going to be 16.0 dm cubed divided by V initial, and that's going to be 12.7 dm cubed. So you cancel out all of the information, mole, Kelvin, Kelvin. Of course, dm cubed. We're going to cancel out because the units just easily cancel. So now we have all of this information. We're going to do negative 0.28055 times 8.3145 times 310. We're going to get that information to be 723.116 joules. Okay, and times ln 16 divided by 12.7. So that would be 16 divided by 12.7. So when you have all of that information, remember the negative. So you have work done is going to actually be equal to negative 911.0123 joules. So yeah, but one thing you have to note is that the work is not actually done. You see that we're giving our information in three sig figs. We have 4.50, we have 12.7. When we add to find V final, we have 16.0. So everything we've been given actually has been in three sig figs. So we have to put our information and round up to whatever we have. We have to do the approximate value in three sig figs. So actually, work done is actually going to be approximately negative 911 joules. So this is our answer. Work done is negative 911 joules. So this is how you answer this particular question. If you have any question, please put it in the comment section. I'll be here to answer all of your questions. If you're a student who is trying to succeed and trying to ace all your STEM related courses, whether you're in middle school, high school, or in college, or you want personal classes or you want to do a group class with a bunch of your friends, make sure you email me at shohabitutoring@gmail.com. If you would also like to ask me a question, you can also email me, or if you want to book a session to see whether the tutoring is going to work for you or not, also email me at shohabitutoring.com. So make sure you do that fast because time is going. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.